Hello and welcome to another Coffee with Developers. I'm here with Andreas Kollegger from Neo4j, who's a bit in the dark, but I guess we can sort that out later on. How are you doing today?
I'm doing well, Chris. Thanks for having me on Coffee with Developers. And I guess I should do the obligatory cheers of the coffee mug, a little bit of Phil's coffee from San Francisco. Cheers.
Yay. I've got mine from a local pottery place.
Fantastic.
But Phil's Coffee in San Francisco, oh God, that takes me back. It's like, yeah, I used to live in San Francisco, and when I see the flat prices now, it's basically like 10 times what I paid back then. It's just absolutely
Yeah, it's out of
outrageous.
control, for
Yeah.
sure.
So what does Neo4j do? When I heard about it, I thought it was like a Vim plugin for Java, but it's not.
Oh, that's a pretty good guess. I've also heard good guesses like, is it a new kind of GPU accelerator? Like, is it like it sounds like maybe it's a graphic card or something. But this kind of funny name, Neo4j, is actually it's a database company, and specifically it's a graph database company. So we've been around for about, I don't know, about 15 years now. I've actually been with Neo4j for about 15 years now in different roles. And I'm currently in developer relations, where I'm a senior developer advocate leading our Gen AI efforts.
That is amazing. I mean, 15 years in one company, that's almost unheard of nowadays. I mean, when I worked for Microsoft, I had people in my team leave after half a year on purpose. And it feels like it feels like it's a good place to be then, and a good place to find a career inside the company. How big are you?
So we're just around 800 people now.
Okay.
And so it's grown quite a bit, of course, over this time, from being a fledgling, a couple of people doing some open source stuff, turned into a real company, and then kind of grew over time. And you're right, like I didn't, to be fair, like when I joined, I didn't think I'd be here this long, but I kind of fell in love with the problem space, sort of like the idea of graphs and what you can do with graphs. And also I loved the company. People talk about how important culture is all the time. And to this day, like from the original people all the way up to 800 people, I enjoy every single person who's part of the company. And like, I just, on a personal level, they're really great. They're great to work with. They're exceptional in their fields. And so I've been, very happy, or continue to be really happy, both working on the stuff and also with the people I get to work with.
So do you remote work, or do you have to go to the office? You're now at home, right?
I'm at home right now, and in developer relations, it's a bit of a mix. So I go to the office a couple of times, honestly, a couple of times a month. Other than that, it's a lot of travel. For instance, I'll be, of course, joining you in Amsterdam in about a day. And then beyond that, popping over to America all the time, sometimes up to Sweden, through various parts of Europe. Increasingly and surprisingly, heading to Paris more often than I used to these days, thanks to Gen AI, really.
But that's cool, because then you can take the Eurostar and it's super easy. I always loved that from London. Basically, like you go center town, not have to come from the outside. And
Absolutely.
you go more to Paris because of the European AI guidelines, or why? Were you working with Mistral, or why do you go to Paris?
It seems like the kind of overall community, both between like the established players and also the startups that are there, there's a lot of activity happening within AI that is centered around Paris. So that we're really just kind of joining in on the activity that's there.
Yeah, I worked for Mozilla, and we had like an office in Montmartre, and it was just absolutely gorgeous, but so expensive.
Yeah.
So it was interesting to see. Now, you talked about graphs. I mean, I think this is why we invited you also, not because you're also lovely, but we wanted to have somebody to help us with a bit of those, untangling a bit of those terms that people throw around, and everybody looks around and yeah, I know about that, because we don't actually want to be seen as somebody who doesn't know about AI right now.
Right.
Now, a graph to me is something that I plot on an X and Y, and it actually makes a sign or something like that. That's not the graph that you're talking about, right?
That is not the graph I'm talking about, but that is a common kind of crossover term. And sometimes people also will talk about, graphical representations, where they mean, kind of drawings of things, and like think that those are graphs as well. So I mean, kind of in the kind of mathematical sense of, you've got some things that we tend to call nodes, and then those things are connected to other things, and we call those relationships. So if you've got two things and they have some shared information from an information perspective, then that shared information becomes, captured inside of a relationship.
Okay. And that part of the database, instead of just being structured data that you have to get out and write the functionality for, the database already has these connections and relationships built in for you to use.
Yeah, that's right. One way to think about it is, we're all familiar with the relational database model, and it's pretty common. And I'll go ahead and just say, the majority, if not all, of relational database schemas somewhere have a join table, right? And between the foreign keys and then the join tables that occur, if every record in a join table turned into a relationship, then the two tables that you're joining through the join table end up becoming the nodes, and that ends up, being a graph. Now, as a database, we've taken that observation of this is a convention about how you model things, and realized that for some applications, it's really helpful to think not in terms of this table of stuff and that table of stuff, but this individual record and how it's connected to other individual records. And so it's more going across table queries rather than doing joins, between two tables.
Which means you don't have to read in all the data, do it yourself. It's a lot less memory consumption, a lot faster, because there's already a connection there. Much like a relational database already is better than a SQL database because it has the things already sorted for you.
That's exactly right. Yeah, and so for kind of the immediate performance benefit for that is if you're doing these kind of, from record to record to record kind of links, you're basically doing pointer chasing at that point. And now it's almost linear time for the number of hops you take for how long a query takes.
Mm-hmm. So one thing that you were excited about when we did the preliminary planning of this talk, which we spent all of 3 minutes on, is basically that you're super excited about the whole RAG space. RAGs and riches and these kind of things. And you basically, again, you can go to Wikipedia, look it up, and it basically means that you have an LLM, you have a data set, but you want to enhance it with getting extra context in from the web, from other things that you upload, and then you keep requesting information for it until you get the right answer. Is this a fair summary, or do you have?
Yeah.
You probably work in DevRel. You probably have a pitch that is very simple for people to understand what RAG might be about.
Yeah, I think the way that you described it is very appropriate. And just looking at the acronym first itself, it is Retrieval-Augmented Generation. And breaking apart what all those things mean, you can kind of ignore the generation part of it. That's just the LLM doing what it does. And we know whenever we're dealing with an LLM that the fundamental kind of engineering that you're doing is creating a prompt, handing it to the LLM and saying, hey, given this text, please predict what is the most likely text to follow. Now, because we tend to form text that ends with a question, the most likely thing to follow is often an answer. And so you end up with these patterns of here's some text that provides some information, and then maybe some context. The word you used there was spot on. Here's some context for, that I want the LLM to be aware of. And then here's a question. Go ahead and continue this text with what should then look like an answer to the question. And so that's the augmentation of the generation. And the retrieval part is okay, how do you get that extra context? Okay, before you create the prompt, you take the user's original question, figure out how to get some information that is relevant to that from a database. And that could be it could be a SQL database, it could be a graph database, or it could be one of these new vector databases. And all you're doing is retrieving information from those. And there's a bunch of different techniques for doing this, but then taking the results, packing that into the text that is the prompt, handing all that over to the LLM, and then the LLM does its thing with the generation part. It's a bit longer way of saying exactly what you just said.
It's the thing is, but the more you prepare, the faster you will get the answer and the proper answer that you want. And that always has been my frustration with any of these chat systems, that you see the animation coming in and you see the thing coming in, you're halfway through, you're no, you're completely going off the wrong path. Can I please interrupt you? And much like you can't interrupt a person in a conversation, often these systems don't allow you to do that as well. And it feels wasteful in terms of energy and consumption power and computing power, that we have to ask the machine 15 times the same thing rather than having something like that. Now, you talk about a GraphRAG. What's that then?
So GraphRAG actually picks up a little bit on what you're observing there, that when you're generating these prompts, you want to give as little information as carefully refined amount of information that is needed for providing an answer as you can. The more extra information you have, the more likely that the LLM is going to go off the rails. It might hallucinate. Actually, even if you've given it proper information, it has, because the signal to noise ratio is out of whack. So you want to have as well-focused information as possible inside of the context. So GraphRAG takes the idea of saying, okay, well, one of the ways of representing information is a graph. So in a very broad sense, GraphRAG is simply doing retrieval-augmented generation, doing RAG, where the retrieval part is with a graph. But because graphs play a couple of different roles in information architecture, one of those roles is that you can just have a graph that is what's called a knowledge graph, where the information itself has been encoded inside of a graph form. you can think about that as being a distillation of the essential facts about some topic. So rather than reading through, 10 pages of text, if you can distill that down to like the essential facts that the text represents, you get a knowledge graph. And now, because you've arrived at a distillation of the information, what you're providing to the LLM, once you've decided what part of the graph is relevant, is all that the LLM needs for providing an answer.
Mm-hmm. And how do you basically implement that? Is that something you need to have you write yourself? Is this something that's built into products right now? Is it something that you provide? Probably it is, but I don't want to sound like, oh, tell me the thing that you guys are doing. But it's like it feels like to me, whenever something like that comes up, it feels like, oh, I got to learn this. But you probably don't, because it's already built in, right?
Well, yes and no, I'll actually say. So because there's a huge breadth of techniques that are available that are basically under the umbrella of GraphRAG, there are very simple ways to get started that have been packaged up very nicely that you can get kind of out of the box, kind of working solutions that will use a graph either as a knowledge graph and then use that for supplying information, or actually even all the way to agentic systems where you have agentic memory that is actually shaped like a knowledge graph. You can just get that as a package and just plug that into your flow. And now you've got a knowledge graph based memory that supports what you're trying to do. For many businesses, though, we find that what they need to do is like at least understand these concepts, but they start with both the structured and the unstructured data that they have. And their first challenge is, how do we connect these things? Because in the same way that I was suggesting that, you can think about a knowledge graph as a kind of a distillation of the information from some unstructured data, over on the structured data side, that's already distilled data. That is already like the essential core valuable data from some business. So your challenge then ends up being, how do I mix this unstructured data that we have with the structured data that we have, and then provide an answer based on both of those things? So for businesses, often the challenge is going through their unstructured data, trying to pull up enough structure out of that so that you can connect it to their business data, and then build a system on top of that that answers the questions you're trying to do. And at that point, they end up back into kind of, I'll say, traditional data modeling challenges, where you want to shape the system to fit the questions you want to ask. That if you have different levels of inquiry that you want to have, or different directions of inquiry, that you will change the way the graph looks and how it connects things based on what you're trying to do with it.
Mm-hmm. Interesting. I mean, the challenge for companies are twofold. Then, first of all, where would people when you said like people have to understand those things, where can they go to learn that?
Yeah. So luckily, there's many great learning resources available. As a personal plug, if you got to deep learning AI, I've got a knowledge graph for RAG course out there that I think is a very good introduction to the topic. It's very slow paced and like kind of goes iteratively through the ideas, one at a time, progressing to like, okay, you start with nothing to like, now you've got a graph, now you can do some exercises with it. You can also go to places like graphacademy.com, where there's a full kind of level of coursework all around graphs and how you work with graphs and think about graphs, and then also apply graphs for doing RAG. And back to what you had observed earlier, if you're not ready to kind of take that step and like, really get into the deep end of like, how does this stuff work? You can just get, packages that work out of the box that will get you enough of the way there that you really get some productivity. And then you can dig deeper later on once you run into the edge cases and you want to tweak the system a little bit. So whether that's sort of GraphRAG packages in Python, or even systems like the agentic memory that I mentioned, which is actually, there's a company called Zep, which, little plug for them. They're doing fantastic work with agentic memory knowledge graphs, and also a group called Cogni as well. Fantastic work kind of exploring all this stuff. I think using the out-of-the-box stuff makes sense as a first step, and then digging deeper as you realize that your needs are maybe beyond what you get out of the box.
The next problem from the twofold problems I talked about is, of course, the quality of your data and where it's stored. I remember working for train lines in England, and we had like 60 different databases across different data centers and 415,000 spreadsheets that they used internally to build things, all of them in different formats. Yeah. So I guess there's a lot of models out there and a lot of agents out there that already help you with cleaning up your own data and distilling it to what you need to do. But is this? Do you see this as a challenge for companies, or as an opportunity to clean up the mess that we accumulated over the last 40 years, anyways?
So I guess obviously a little bit of both. For many companies, the motivation here to actually even kind of go down this path, whether they're using a graph or any other technology, is exactly what you're saying. They already have data either in a bunch of PDFs, like terabytes of PDFs, or they've got, dozens and dozens of different spreadsheets. And they're like, hey, maybe this is an opportunity to take all this data, bring it all into one format that we can actually do stuff with, and realize some of the information, some of the valuable insights that are inside of all that data. Know more about your company, know more about your customers, know more about your logistics, whatever it might be. And the first challenge, of course, is the classic challenge that we have had forever inside of any kind of information architecture is data preparation. Going from that messy data, whether it's a spreadsheet, you can get some CSVs out of that, or it's the PDFs or anything else, and taking that into a structured system, at least a little bit of structure, and then refining it over time. So first just ingesting it at all, and then probably changing it a little bit slowly, probably from my perspective, of course, evolving a graph out of that as well. And I guess I'll say, like, for the graph aspect of it, graphs can seem like, okay, seems like a lot of work, like to just kind of wrap your mind around, like, how do you actually work with these things? What's nice is you don't have to pre-plan. Like again, a little bit from relational database land, when we were used to working with data before, we always worried about trying to have a good enough schema up front so that we don't have to do any data migrations. That's always kind of in the back of our heads. There's a little bit of a fear of like data migration. With a graph, particularly with unstructured data, you can let it evolve over time. You can iterate over it, and like nothing ever becomes outdated. You can just add to what's there. And so it can evolve as your needs evolve. You don't have to worry about having the perfect kind of schema going into this space. So you can do a little bit at a time and start with what I like to refer to as the minimum viable graph, and let that evolve as your data ingest comes in. You realize there's more information you want to take advantage of. The other aspect that I guess I'd mention that's nice is that, and this is again, a bit of a graphy take on these things for sure. When you start to ingest this data, and first you just have what people call, chunking is usually the thing people do with unstructured data, and it'll happen even like with things from like a spreadsheet, because you've got CSV files that probably represent records. You want to kind of divide this into records. Sometimes they represent multiple records. You want to try to get to that into structured data of some kind. But as soon as you start to connect these things, a couple of things happen. You've got data that you can go from one piece of data to other pieces of data. So you have this kind of cross-linking, which is a little bit of like a relational foreign key relationships. And so that's nice. So you already have a way of like saying, okay, this data is not isolated. I know when I've got this chunk or this record that I can correlate it with some other chunks and records, and that's great. But because they are correlated, and if you have a graph mindset about this stuff, you can already do some interesting analytics on the data as soon as you've imported it. Even without creating a sophisticated knowledge graph or having ontologies or anything else involved, just because things are connected, you can start to ask questions like, okay, what is the most referenced piece of information I have? Or given this piece of information and this piece of information, how are they connected? And you can start to connect things because these are all graph operations. So as long as you have kind of connections between the data, you can really get some more valuable insight. Each of these insights hints at kind of what I'd call emergent information inside of the information. You've got the individual pieces of information themselves, but as soon as you collect them together, the collections themselves, the information is greater than the sum of just the pieces. That old adage always, continues to be true, and it becomes even more relevant with the graph approach.
What I find interesting is as well as how far we go back to like very, very basic data formats. CSV or TSV, which I'm really excited about because you never have tabs in a normal text. Like it makes actually more sense than having to put the quotes around all the data. And Microsoft has a lot of tools to actually turn things into Markdown, scrape websites and turn them into Markdown to make them. People are generating text files for bots on the web to index, for AI bots to index. It feels like we're really going back to that. And I get these flashbacks to when I worked at the beginning of the 2000s. In England, and everything was XML and SOAP and like all the different very, very detailed and also sometimes super open like XML, but sometimes like super like closed data formats that we had to use. And I worked for the UK government. We had a lot of stuff that basically was just like everything had to be signed before you get the data back.
Yeah.
So one big worry that companies have, of course, is like, where does my data go, and can my data leak somewhere else if I use an AI system? So is this something that you have to deal with as well, or is it more like you just put things in a database and we find it out for you? Or is this a worry that you share with a lot of people?
I do share that concern. I'll have to say that you have to put a lot of trust in your providers, so whoever is providing your LLM service, if you're using OpenAI or if you're using Grok for that matter or anything else, you've got a lot of trust in that system. And if you're concerned about leakage, then the best thing, of course, to do is to run your own LLM. Now, that's probably not a first step anybody should ever take, but it is an eventual step. And for many companies, between data privacy and also having control over their own data, and also being able to know that it's not getting out anywhere, like having kind of governance over that, it is an incredibly important thing. For just having a chat with an LLM, it doesn't matter so much. If you're a little worried about like your personal, interests, being exposed to the LLM, okay, that's maybe a concern. But if it's the kind of thing that you might Google anyway, the LLM is not going to know any more than Google does about stuff. So if you feel comfortable Googling things, you should feel comfortable about chatting with, any of the LLMs with that. So Anthropic or whoever. But from a business perspective, totally different ballgame. And there, I think having direct control over the LLM is critical. And also for any of the fine tuning that you eventually will probably want to do, having your own LLM is really the way to go.
I love that the pendulum of open to closed is swinging like heavily right now. Like we always said, like, okay, like there's going to be OpenAI, which is open-ish, and then there's Grok, which is like we don't know, like, and there's basically all the systems that just trust us, and we give us data and we give you the coolest answers. And then DeepSeek came out and basically completely blew everything out of the water, being open for starters, open source. But what was the thing that DeepSeek did that actually, I mean, I see all the headlines, it uses a lot less memory, it uses a lot less computing power. What did they do differently that others can now start learning from or imitating from? Why was it such a shock to the system?
Yeah, I think the first shock to the system was not actually their technique, although that's really interesting. It's to do with like that a small group on their own with less resources were able to reproduce really powerful LLMs, and then we're happy to go ahead and open source. It seems like increasingly their entire approach. The current news is that like they're expecting to actually release even GitHub repositories about like, here's how we did stuff, here's how the training looked like. So not just the weights and things, but also all the way down to like, here's the code that we use for doing eval. I don't know what else they'll release. That completely changes the game, where the open source world, and it is back to one of these pendulums. It is not just you have to trust private, companies for these things. Now, the open source, if that is at the same level of quality as the closed source, well, what are you really getting out of the closed source models then? Like if they were always 10 times better, then that's one argument. But now if they're comparable, and this isn't orders of magnitude difference, they're comparable, right? That the motivations to the kind of the financial incentives change quite a bit. Now it's like really the cost of operations rather than that you've got something unique that's going on. And a little bit that changes the dynamics within even funding, because if you're going to try to like raise funding, you can't raise funding based on, oh, we have this unique solution. That is no longer differentiating. If you can have an open source model that does the same thing, the funding is purely based on market share and resources that you have, at your disposal, perhaps your own personal nuclear power to actually power the data centers.
That's also worrying, isn't it? That we turn on lots of nuclear power plants again just because we want to generate image of like owls on skateboards or something. It was interesting to see. Of course, there was the China versus US thing happening there as well. There was the other problem with it, and like one of them was not giving information about a certain topic, whereas the other one didn't give you information about another topic.
Right.
But this is, I guess, where the RAG approach comes in, where you can bring your own context in and say, like, okay, this information is missing in the LLM, but I can actually enhance it with the information that I want to have. One of my concerns is immediacy and quickness. Like a lot of I've seen a lot of posts lately about news and basically news being summarized by AI. And all of them are completely failing at it because it's like the data sets, the weighted data sets behind it are like 2 to 3 years old. And when something happens immediately, it doesn't have the context of what happened last week to make that thing happen right now. So this is something that we need to fix to actually either be very transparent about it and say like this information is so and so old, that's why I can only give you that one, or by having a system in between that's like a information firewall to the LLM with your data. Like basically that's just like, okay, that's old, but here's the new stuff coming from the web, and where's the quality of that? That's the other issue then as well.
I think there's going to be kind of a lot of the things you and I have learned and everyone in this audience has learned over time about software engineering is going to continue to be relevant. we've run into these kinds of problems before. We have lots of different approaches for how you solve these things. And like the obvious thing to do here is, of course, oh, let's do this as a stream-based processing so that we have a constant ingest of information and that is constantly being put into the system. And then, that system is then being used. Now, the easiest way, of course, to do that is to not have a centralized LLM, but have a specialized LLM whose job is only to do that. And like it is basically continuously fine-tuning. So you could use RAG for it, but you could also have it constantly fine-tuned for data that's coming in. That's the other aspect of the kind of the open sourceness of DeepSeek and some of the things they've done with distillation, where you can have smaller and smaller models that are also really powerful. And we're seeing that not from just DeepSeek. Lots of people have like mini versions of their kind of headlining models. That smaller models are continuing to be improved themselves. That they're almost as good as the big models, but take much less resources. And like if you continue following that down, there are then specialized models that are even smaller. People talk about like small language models, and then even tiny language models, and some people talk about nano language models like that for the basic kind of techniques that we've realized that depending on what you're trying to achieve, you can get smaller models that are then very localized and also very local running. They don't have to be a central service. They can be running on your watch or on your phone or on your local machine. And so you can get your own news summary based on your preferences because you've got a local model that knows about you. So this is where agentic really becomes interesting, because now it's a combination of local models that are really your personal co-pilot, your co-agent, your partner, however you want to think about them, plus being able to access the files that you're creating. It has access to that. We already see computer use is one of the things that people are doing with agents, so that the system knows how to see the screen that you're interacting with. Or if you're doing coding, all of the files that are on the disk or inside of a project are available to that agent. And those agents don't have to live off in the cloud anymore. Having local resources for running that stuff is going to be increasingly interesting. And it'll be agents all the way down. It'll be agents all the way from the Anthropic, ChatGPT level, all the way down to running on your local machine, all the way down to embedded devices. That's one of the nice things about the evolution of LLMs as we're going forward.
I love that this becomes a kind of naturally part of operating systems anyways. I mean, it fascinates me, for example, on when I worked in Windows or in Microsoft, we always were like, how the hell is Spotlight on Mac so much faster than anything we have on Windows? And it's partly the file system, but it's also partly the indexing thing. That's why they got the DS store files everywhere that basically drive every Unix or Windows user bonkers when you have put them in your GitHub repo. But today, for example, I searched things and it actually finds the text in images. So basically the file name of the image was nothing sensible, but I searched for a certain text and it found the text inside that image. And that's something without much fanfare just became a normal thing in operating systems. And I guess we have a new generation of computer users that don't even know what a file is any longer. They just have data on their machine.
That can be true, yeah.
They need an agent or something like that to tell them like, yeah, you did this. Or you can do searches like, show me all files that are at least a week old and over 12 gigabyte, like natural language processing in search boxes. I love that these things are there. I'm kind of worried about the agent thing, that like we're going to have an agent for everything, as you said, like agents all the way down. Like it seems maybe it's just an old man thinking like, I have so many threads running on my machine, I don't know what's going on any longer. Like, will there be race conditions of agents trying to give you different information pieces? What's the UX going to look like to give you that information?
I think those are great concerns. I think exactly like from the user interface kind of it all and the user experience of it all, there's a lot to be figured out. But I think you're right. The resource contention is not something to be ignored. But I do think that from a developer perspective, that is my favorite feature of agents, is that sometimes when you read the literature and you listen to OpenAI talking about agentic, or even Microsoft or Anthropic, whoever, they talk about agents as a way for the LLM to gain access to your local machine or to do research for you, or to do all these things, as if the purpose of an agent is to extend the powers of an LLM. I think completely the opposite way about that. I think we should totally invert that. For a software developer, we should just think about agents as the composable unit of LLMs. That this is a software design pattern, and it's the same as anything else that we know how to assemble. Here's how it's encapsulated. Here's what it does inside. And then we have these things that we can actually put together in different patterns that do different things. But now it's a software development resource rather than, oh, we're giving power away to some LLM. No. Let's turn that around. From a developer's perspective, this is how we control LLMs. This is how we manage LLMs. This is how we both allow them to have access to things. We can apply our normal kind of access privileges to the LLM itself, because now it is a unit of software that we're working with. We can pick any, kind of pattern for dealing with side effects that we want to. If we want to do promise-based or even have an actor-based version of agents, sure, you can do all those things as well. But having an agentic perspective on LLMs and doing RAG suddenly changes it all, I think, even more strongly into being, this is just normal software development now, where inside the function call, stuff happens. It's a side effect that happens, fine, but it's still just a function call at that point.
It feels like yet another level of abstraction that we need to deal with. I mean, I remember writing like animations directly to the chipsets on like old machines, and now we have tons and tons of embedded systems in the embedded methods in the graphics software itself, in the graphics hardware itself. So we don't need to think about like how blitting works, or we don't have to actually think about how the rendering works, because the graphics card and the SDK around it does it for us. So it seems like in the LLM space, that's like feels the same thing, because I always was like worried as a security conscious person and a privacy conscious person that we have these black boxes of LLMs that just tell us, we give us magical answers, but I don't know what's in there. I cannot look into it. And as you said, like with an agent, it becomes composable for me. It actually makes it more approachable to me. My favorite is when people talk about the multimodal agents, and they're like, oh, now it can see the screen that you're doing, and it can access your camera, it can access your microphone. And I'm like, that's what malware and ransomware did trying to do all the time. And we now give it away for free.
And I can monitor your keystrokes, and I know your search history. And yeah, it sounds very ominous at that point. You're exactly right, though. Like it has all kinds of scary parallels, but at the same time, the hopeful aspect of all this, if we get out ahead of like the possibilities and start to like think about it from a software developer perspective, I think we know how to put guardrails in place between having an agent that is localized, that is going to have a reduced amount of memory, but have some ability for doing reasoning, but then has tools that it can call, where each of those tools come back to RAG. At that point, once you're calling a tool, this is, the tool can either take an action, like, click the mouse button for you, or it can also retrieve information. So RAG comes back into play even within an agentic system. And all of that, though, is nicely encapsulated inside of an agent. And now it's a composable unit that we can work with. We can do the resource managing around it. We could preferably have, when we're doing, a PS on our system, we can be like, okay, there's the agents running. This one's taking up a lot of resources. You should be able to ask the agent what it's doing, see its decision tree, see the reasoning traces about, where it started, what it's continuing to do, why it's still operating. There's a lot to catch up on, but it isn't as foreign as it seems right now. Like we're getting closer and closer as things evolve from what was really kind of, and I love data scientists, but what seemed like this obscure stuff that data scientists and machine learning engineers were doing, it's turning more and more into like, oh, this is normal software stuff now. And like all the software kind of design patterns that we know about, all the software discipline that we know about, even things like choosing whether to pre-compute some answers or do them dynamically on the fly, that kind of trade-off. Do you have enough storage? Do you have enough CPU? All those trade-offs still apply even inside of agentic systems. And all of those kind of concerns are normal day-to-day software development concerns. We're starting to gain control over this stuff.
Cool. Well, one thing you said here is like one question that you want to answer is like, why GraphRAG instead of regular RAG?
Oh yeah, that's right. We haven't touched on that. And so I think that regular RAG, generally when people think about RAG, the assumption is you're doing retrieval-augmented generation with some unstructured text, and vector similarity search is the basic way that people do that. And I guess I won't get into the details, but like, vector similarity simply says, given some user question, like I've asked, I don't know, where have I left my coffee cup? Okay, that's going to be a hard thing for it to answer, but let's say I ask that. Okay, that text turns into a vector, and vector similarity simply says, okay, let me do a lookup for that vector into the vector space and find what information is in that same vector space. So a vector search is basically like doing a fuzzy lookup for information, where the information that you're hoping to pull back resembles the question that you've asked. So if somewhere in the information, some bit of text, let's say, says, oh, ABK's coffee cup is on his desk, fantastic. Then actually, that kind of vector similarity search works great. You can actually just grab that text back, hand it to the LLM to provide the answer, and hopefully it doesn't mess up trying to provide the answer. Okay, APK's coffee cup is on his desk. That kind of the gap here, though, the challenge ends up being when you're doing more than a simple lookup, or when the lookup isn't available in the text, or is maybe available in multiple parts of the text. And earlier in the conversation, we talked about context, and that's one of the critical aspects that you run into kind of on the second day or third day of doing stuff with RAG, where initially it seems amazing, because it is amazing. You ask some questions. If the question has an answer, you get that answer back. It seems fantastic. When there's gaps, or when you're getting the wrong information back, it's not even the LLM hallucinating. Sometimes you might get a match that is similar to the question you've asked, but is irrelevant for answering the question. And one of the examples I like to give is there's a data set that we play around with from the SEC, which is at least as of today, Security and Exchange Commission in the United States. I don't know if that's been disbanded yet. Well, I'll check the news. But assuming it's not been disbanded, they manage kind of publicly traded companies and also investors in those companies. And when you're a publicly traded company, you've got to say, okay, here's our current business profile for the coming year. Here's where we're investing into, internally what our priorities are. Also, here's the risks to our business, so that investors can be equally informed about what matters, about investing in that business. Now, if I ask about what are the biggest risks to Apple's business? In the text, Apple doesn't talk about itself a lot. It doesn't say, Apple thinks this, Apple thinks that, but somebody else who's maybe a partner of Apple might be like, oh, well, we see Apple's biggest risk this year as being X, Y, and Z, and so we're going to do this, because they care about talking about Apple. So talking about Apple will have greater similarity to the question than Apple's answer about themselves. And so the context about the text matters. And so that's one of the things you get out of GraphRAG, is that it's not just the text you get, but as soon as you've linked it to other text, you can be aware of the full context. You can realize, actually, it's not just about Apple and risk. It's about two separate pieces of information that you need to connect. Let's go find Apple. Let's go find text about risk, and make sure that we have those things connected very directly, so that it's Apple who's authored information about that risk, as an example. That kind of gap in context continues to play out in lots of different, what would feel like corner cases, but this is where people spend a lot of time trying to tweak their RAG system to get it right. The thing that they're trying to tweak is this lack of context.
And the last thing you talked about, graphs are simple. Why do they seem scary? Simple is always a very dangerous thing to say, isn't it?
It is. Yeah. And when we started talking, I described graphs as simply being okay, you've got these nodes and relationships to other nodes. We can draw that, you draw a little circle with an arrow to another little circle, and we can think about that, and that seems really easy. That said, kind of a lot of the things we've talked about, during this time also expose that working with graphs can be a bit intimidating, because the simple concept isn't necessarily simple to work with. And I think there's two aspects to that. One is that on a day-to-day basis, developers have familiarity with things like sets. Every major programming language has some notion of a set, and set-based thinking maps really nicely to tables and to relational databases. And so that's something we can kind of understand. We also know about maps. Most programming languages have some version of a map or a dictionary, whatever, associative, array, whatever you might call it. And that's the same thing that the map maps directly to a key value store. So even if you're using something like, MongoDB, that's fundamentally a key value store. Here's a key, get me the value, and the value happens to be chunkier. Or if you're doing vector similarity search, it is also still really a key value store. It's the key ends up being much fuzzier. It's this vector that you're using to look things up, but then the result comes back, happens to be some text. Pretty simple to work with. With a graph, there isn't really a major programming language that has a graph data structure that programmers use on a daily basis. We at Neo4j, we say all the time that graphs are everywhere, and it's easy to observe graphs all around you, but they tend to be kind of an emergent feature of what you're doing, rather than something that you're directly working with. And so that's for me, one of the initial kind of stumbling blocks for folks is that they can kind of intellectually say, yeah, I get what you're saying, but to really kind of intrinsically kind of feel what I'm saying and understand the implications of it takes a little bit of extra work. And one of the ways that I address that for programmers is that I talk about how for graphs, the thing you end up doing is doing pattern matching. And we all know and love regular expressions. or at least know of, regular expressions. And pattern matching ends up being how you work with graphs. Once you have data in a graph form, you just think in terms of pattern matching. Describe a pattern, even repetitions within a pattern, and that's how you fetch stuff from a graph. So that ends up being really nice. But you had to get people through kind of some mental hurdles, because on a day-to-day basis, you don't really work with it. The other aspect, particular to Gen AI, is that the research in this area, both from how you construct the graph and different techniques for just creating the graph in the first place, to connecting the data that is unstructured to the structured data, to the different access patterns, there's such a huge breadth of opportunities available that it can seem too intimidating, because it's hard to know where to get started. And I'll go back to what I said earlier, that is true, that can be looked at. And of course, I look at that as a huge, diversity of possibilities that are open in front of you once you start to go down the graph path. But knowing where to start is really the challenge. And it seems like, okay, let me put that off for another day. I don't think that's a mistake. Actually, I think that's probably the right thing. Let people get started with doing Gen AI and RAG first, and then eventually, I think a little bit like Thanos, even though Thanos is a bad guy, graphs are inevitable. You're going to find yourself basically creating graph structures and using graphs, whether or not you start by using graphs. So that's okay. If you don't do that on the first day, I know by the second or third day, you're going to start realizing why and where graphs fit.
As long as you don't snap your fingers and half your engineers are gone, then you have
just
another
don't
topic.
fire.
Let's
That's
not
right.
go down too far down that topic. So, do you think there is a space for a programming language that has a graph-based approach? I mean, it always cracks me up that machine learning was around for a long, long time, and then we came up with F#, and we came up with R, and all these languages that are focused and optimized for that kind of environment, and then everybody uses Python. Like, do you think that this programming pattern of a graph could be something for a new language to emerge, or is there no space for that?
I think that there is an open opportunity around this. And I'll actually go ahead and reference, there was a great podcast with the Pydantic AI folks. So the Pydantic folks have released their own RAG package for how you actually do agent systems with Pydantic, because everyone uses Pydantic anyway. So they're like, okay, we're going to build our own framework. And internally, they already had this debate about, like, should we have a graph representation or not? And initially they were like, no, that seems like too much extra work. We're just going to do kind of some straightforward stuff and just do regular programming. Everything will be great. And use case after use case after use case, they're like, oh yeah, that'd be great if it was a graph. Oh yeah, actually that would be easier if it was. And like, they eventually came around to the point where they realized, actually, they, at least internally, they know that they want to use a graph, and their fundamental operation is graph based. And at the same time, what they expose to users tries to keep users from having to directly deal with a graph. LangChain, which came out of LangGraph, which came out of LangChain, has kind of the same story, where they started with the idea like, oh, they realized that graphs are awesome, which is a great realization. But then they've kind of backed off from that a little bit, and they're trying to find ways of allowing people, I should say, to start to create solutions that don't directly rely on the graph, but that the graph then ends up falling out of it. Might be how it's executed. It's the kind of behind the scenes thing. So I think a lot of that's going to end up being true as we progress, that people will kind of flirt with this borderline between, we know it's going to be a graph, but how do we represent it maybe in not quite a direct graph way? I think there's something there that is an open opportunity for somebody to come up with a solution for.
Yeah, and that's what I love about it. I mean, we always say like, okay, AI is now coming for the developers. It came for the factory workers. It came for that. It came for the, I don't know, like people that do taxes. And now that developers thought like, oh, we're always needed. And now it feels like, are we really anymore? But then there's always these opportunities. I remember when you earlier said like you can paint something and do a thing. And then I got flashbacks to UML. And now I have to actually curl up into a ball and cry, because that's something I'm very happy to see the back of. But yeah, it feels like there's an academic approach to things, but I love that with the speed of innovation that we have right now, the academic thinking about programming and the implementation of it is becoming shorter and shorter. And I think there's lots of opportunities in that regard. As you said, like we need better ways to deal with that rather than just like rely on one big LLM to give us the answer.
Yeah, I've heard somebody comment that like there's this almost kind of Maslow's hierarchy of ideals, kind of thing at play here, where of needs, where for developers, we spend so much time on like boilerplate code and like writing tests and a bunch of, trying to figure out dependency problems, whatever it might be, that takes us away from the actual interesting parts of programming. My optimistic view is that like all of the new tools we're getting out of Gen AI and out of LLMs are going to help us just stop having to worry about all of the annoying stuff and go back to just the interesting problems themselves. And we're going to like elevate our thinking rather than having to worry about like just the kind of mechanics of how to get stuff done.
Cool. Well, I mean, we have like 45 minutes. That's more than one coffee. So that was great to talk to you. We have an event coming up on the 27th of March about like a live event again about AI and development with lots of like conversations and stuff. So it might be interesting to get you involved in some degree as well. Are you coming to the Congress in Berlin in July as well?
I haven't made my plans for July yet, but I would like to, yes. Excellent.
Cool. Well, with that, I thank you very much. This was ABK of Neo4j. You talked about graphs, you talked about RAG, and I'm coming out much more intelligent now, or I can say things that sound more intelligent than before, and hopefully you as well, and you as the audience. I know you do already. So, any last words for you? Like, how do you get the scariness out of graphs away, and what should people take a look at right now from your point of view?
I think both for graphs and also broadly for Gen AI, if people haven't stepped into that world yet, you will get a little bit of initial fear that, oh my God, there's so much to learn that you're not familiar with yet. The good news, both on the Gen AI side and on the graph side, is don't worry about everything. You can just do small things, and those small things will pay off over time, and you'll build incrementally, and then you'll be off and running. It seems like a lot to take in at once. Don't worry about it. Don't worry about reading the latest research papers. Just start doing some work and it'll lead you forward. And the same thing with graphs. Just start with a little bit of graphs. Just realize, oh, these two things are connected, connect them, and just look at what you've done and see what interesting things you can do with it. And over time, that will build into its own interesting kind of solution.
Thank you so much. This was lovely. See you soon.
Thanks, Chris. Bye.